Have you ever closed your door to get more privacy at your home? Whether it be from your parents or your younger siblings, so that nobody was able to hear you when you're on the phone or talking to a friend? This is a result of wave diffraction, the bending of your waves, whether it be your sound waves if you're speaking or light coming from your room, the bending of your waves. So when we talk about this, we're talking about Huygens principle. And a wavefront is made up of something that is called a wavelet. Each wavelet is a point source of circular waves. We already know that waves take a circular or spherical three-dimensional shape. Wave rays are lines that are perpendicular to wavefronts that show wave travel direction. So you have all of these little wavelets, all of these little circular point sources for our waves. These wavelets are these vertical lines here that are traveling out from your waves. And these lines, these yellow rays, are what we call wave rays. And these are perpendicular to your wave front such that your vertical and horizontal lines are forming 90-degree angles. So what happens when you have a barrier that blocks part of your wavefront? In an ideal situation, you just have your wavefront and they're traveling outward, and the sound or the light for that matter will just continue to travel outward until it reduces in amplitude or reduces in energy. But what happens when you have a barrier, such as a door in your room? Well, when you have a barrier, these wave fronts bend as they turn and curve around that opening. If we were in school and we were talking about this principle, we would have some of us go in the hallway and some of us would stay inside the room and see if we were able to hear what was going on being out down the hall from our classroom. Do you think we'd be able to hear? Of course. That's why you're able to hear as you're walking down the hallway and hear classes that are very loud. Well, you're able to hear this sound or see the light emanating from the room because of wave diffraction, or the bending of these waves as it travels through the opening. These wave rays, the rays that produce what we see, bend and turn around the corners of the opening. So when we have diffraction, this is when the opening is much larger than the wavelength of your wave. And when we mean the opening, we mean the opening of the barrier. So depending on how wide your barrier is, will produce little or more diffraction depending on the width of the opening. So if you have a very large opening, you have little diffraction. You have a lot of room for your waves to travel through. If your opening is small, such as in the second picture here, you have much more diffraction and a larger bending of your wave. You can see that your wave is much more curved in the second picture and not as curved in the first. So just to review what we talked about last time, we have reflection, and we know already that reflection is the law of reflection. The incident is equal to your reflected ray. This is the law of reflection. We also talked about diffuse reflection, where your incident angle is always equal to your reflected angle, except now your surfaces are at different elevations, which means that you are going to have different angles of reflection for each different ray. We also talked about refraction and the bending of your wave towards your normal or away from your normal. We talked about what it means if you're going from a more dense to a less dense, or a less dense to a more dense medium. And the last thing that we need to discuss is something that's called polarization. So polarization is the filtering of waves except those with particles moving in certain direction. This concept, this phenomenon of polarization, only works for transverse waves. Longitudinal waves cannot be polarized, which means that sound waves cannot be polarized. If you go to the store and you want to purchase sunglasses, you have the option of buying polarized lenses. They're more expensive, however, it's safer for your eyes. So, as you can see in this picture, you have these waves that are going to be traveling towards, say, the sunglasses, and you look on the other side, only vertical waves, these waves that are traveling perpendicular to your wave motion, also known as transverse waves, are able to go through. So only electromagnetic waves can be polarized, sound waves cannot.